Today I thought, well, we've started designing, but again, I know there are some of the design principles that most of our members here are not aware of. Even those people who've been designing for several years, for several months or something, or you've just entered into the PCB design. So there are some concepts here that I want us to know what they do mean and whatever they entail about. So talk of what's a PCB. I've not even mentioned this so far, like what does it mean? So the initials themselves, if you're not quite aware of this is a printed circuit board. And basically how a PCB is formed is that it's formed out by etching out big copper sheets so that you're only left with the traces that you want. So in essence, the PCB is usually a very big board that's covered with copper. Then you etch out the copper sheets. You etch out whatever you don't want so that you are left with the coppers that you need, so that it provides some good electrical connections. So components are also again placed directly on the PCB, as you've already known this and you've seen it before. So what materials are used in PCBs and what are the classifications that they do come with? Well, we do have several types of classification. We have 3 of these, as you can see them here. We have according to reinforcement, resin types, and according to flame properties. The most commonly used material is one according to reinforcement, which uses epoxy glass. And the type of cloth itself, whatever that is used, is FR4. So anytime you are going to select out like the material and you want to print out a PCB, the default selection will always be FR4. So just go with FR4 for now, and you can dive into the other classifications later. So what are the parameters to check here when you are dealing with PCB itself? So we have to talk about the board thickness. You can opt to change the thickness of the board depending on your application, but the default board size, if you don't change anything when you want to do fabrication, is usually 1.6 mm. The board size, this is the outline of the board, say the dimensions. The material, I've talked about this, which is FR4, and of course the number of layers. So you have to check, you have to check that also when you are sending out your files to the fabrication houses, like the number of layers, 2, 4, 6, and they go in even numbers. Traces. This is the electrical conductive line or wire on the PCB. It's usually etched out on the big copper sheet on the PCB material. So, and these are these lines that you see here. So these lines here. So these essentially these are the traces, or rather the wires that I used to do that. So what are the parameters to consider here? You have to consider the trace width, the clearance, and the spacing. So when you see in a selection that you are given like 6/6 mils, this means that the minimum trace width should be 6 mils and the clearance for that particular trace should be 6 mil. So this one, the first number shows the trace width and the next one shows the clearance. So always when you see this, that's what that means. So it's good to watch out the minimum trace width that a fab house can do, as well as the maximum when you are doing your board, because some boards are very small and you need to go with very small width. You remember how we set the width? So I'll keep on switching on from that board and this one. So this is a board that we'll be using for this particular case, so that I can do the demonstrations here. So remember that this is when I double click here, when I take the selection tool and double click here, you will see the properties of the track width. So for instance, this is 0.30, this is 12 mils. So if I want to change the width of this, I can just come here. Say when I'm drawing a trace, I can select it from here. But if I want to change it, a one that I have already drawn on my board, just remember, select one of these, hit I or U on your keyboard so that it selects the whole wire or the trace. Then hit E on your keyboard. Then you can adjust, say like 10 mils, and it will automatically change. You realize now this one is much smaller than this one. So those are some of the things to consider, especially when you are doing selection and especially when your board size really matters. So I'll go back to my slide here. The next thing is pads and holes. So if you are new here, especially if you are very new, you've heard us talk about pads and holes. You probably don't know what a pad is. So I've given this, that these are mechanical drills on a PCB. We say that usually pads, now here I'm going to the difference between pad and a hole. Usually pads have electrical contact rings on the holes as an outline, while holes do not. And I'll show that here just now. They are grouped into two. We have NPTH and PTH, where NPTH means non-plated through hole and PTH means plated through hole. Meaning that plated through hole, it means that we have some copper connection going all the way through into that particular hole itself. But for the non-plated through hole, we just have like a normal through hole, as you can see here. So this one here is a plated through hole, and this one is just a direct through hole, and you can see it here from this PCB. And so through holes also, they can be plated or non-plated, say like mounting holes here. So in most cases, non-plated through holes are mounting holes, and of course, say like holes for studs for some components and stuff. But pads now, pads are these, they are always found on PHT components, remember, through hole components. So everything you see here, these are pads, the one you see with the gold plating. So when you are doing your holes on your PCB, what is it that you have to consider? You have to consider the finished diameter, because once the diameter is done, some diameter will be taken by the size of the pad itself, the copper and how it takes. So just minimum, but of course you have to check with your producer. Check the minimum clearance as well, and of course the minimum annular ring, and we are going to come into annular ring just later. So let me just do a quick demo on the pads and stuff for those of us who are new at least. So in KiCad, typically this is a pad and this is a pad, but this one here, this is a hole. So I can do this. What I'll do, say you want to see, you can do this and see it in, say, 3D. So you can see this. You can see the difference now between a plated through hole and non-plated through hole. So this is NPTH and this is PTH. So you can easily identify them and where to use them. So I'll go back here so that we can go to the next principle here. So we're going to talk about vias. Of course, you heard me talk about vias when we were discussing about routing a PCB, where we'll say, let me hit a V here to get a via so that I can go to the other side. So via basically comes from a Latin word, which means path or way. So basically, vias are electric connections between two layers that goes through the plane in one or more adjacent layers. And of course, we're going to discuss about the different types of vias that we do have. We do have through vias, blind vias, and buried vias. So let's see what's the difference. Through hole vias, or rather through hole vias, are ones that now go through your FR4 material, say from top, all the way from top to the bottom, as in it actually penetrates from the top of your FR4 material all the way to the bottom. So it's something that you can, even when you check, you can see the other side. So what about a buried via? So a buried via, this is a via that, of course, you will get this type of via, say from, if you're dealing with 6 layers, not 4 layers, of course, it's difficult. You can't get, well, we can do a 4 layer, we can do a buried via in 4 layers. So it's basically a via that, so that it's slotted within the layers. Say we have a 6-layer board, we can have one moving from layer 2 to layer 3. Yeah. So that's a buried via, such that you cannot even see it from the top. What's a blind via? A blind via is one that runs from the top layer or the bottom layer to some inner layer, but again, it does not go all the way through. So, but again, there is a caveat here when we are dealing with blind vias and when you are doing them. And of course, I'll show you how we do them in KiCad, of course. So, how we do this, the parameters that we need to consider here, they are the minimum width and of the annular ring. I'll be coming to annular ring as well, the drill size, and the aspect ratio. This is very important when you are doing blind vias, and of course, and buried vias as well. And that's why we are talking, when we talk about micro vias, we are talking about buried and blind vias. So what matters here is the aspect ratio, and this of course will come from your fab house, but in most cases, I'll highlight how this goes. So let's do a practical application here. Well, this board is not a very good case because it's not a 4-layer board. Let me grab a 4-layer board here just now. So that at least I can do a very good demo in terms of how you do this and how you can select it in the future or something. Let's just discard that. So I'll quickly grab a 4-layer board here. So what I'm doing here for those of us who maybe have joined us. So I want to do a demonstration here for the blind via. Wow, I can't find my PCB board here. Let me see. Let me open another board here. I have several 4-layer boards. Let me open this one. Okay, fantastic. So this is a 4-layer board. So let's say we are doing a trace here from this ground and we want to do a buried via. Or say, let's start with a blind via. So what you do, you right click and you say, place blind or buried via. So at times, you see what we will tell you that blind or buried vias are not enabled in your design settings. So what you basically do, you go to your file here, go to board setup. Then you come here to tracks and vias. Then go to basically design rules itself. So you'll say allow micro vias and allow blind vias. Yeah, and then you just hit OK. So when I come here now, and I can say now place, I can say place blind via. So it will, and you will see it will be very different. So I'll place this, but again, when I check it here now, it can show me where it's running. But you see, for this case now, it's telling me it's starting from front to bottom, which this is a through via, and we don't want it this way. So what you do here, we change this. We want it to be a blind via. So, and again, we want it to run, say, from layer 1 to layer 3, where we have ground to layer 2. So I'm going to select ground here and hit OK. So, and you see how that looks like. This is a buried via now. This is a blind via. It runs from the top layer all the way to the second layer. So if I want to do a buried via, I must have been again, say, in the middle layer, like the ground one here. So let's say I'm on the ground layer. That's the second layer. So I'll hit here. So you see the trace color here. So what I'm going to do now, I'm going to place a micro via. I have hit that. I've placed it there. But again, now I don't want to go to that layer. So I want to go to the third layer. So I'll hit that and select. So let me see. So this it's giving me the top layer. So what I'm going to do here, so I can hit E here or double click on this particular via. Then I want it to run from, I don't want it to run from this. I want it to run from the second layer all the way to the third layer here. So that at least now I'm having a buried via there at some point. And so you can see, so what we've done here, basically, we've connected now this is a buried via, and it cannot be seen anywhere in the design because it's sandwiched within those particular layers. So, and if you want to see this in KiCad, let me do this. I hope you will see it. I'll show you. So if I open my 3D view here, I go here to file properties here, and options, let me see. Display options, and I will say show. I want to show so that we can at least see the inner layers. I'll say show body. No, let's say show body. I'll hit that. Okay. So once I uncheck that, you realize that now my KiCad now you can see inside how we see the layers, the vias, and how they are interconnecting. You see here inside. So when you disable that feature, you are able to see like now how things are connecting. And if we go to where we did the buried via. Or let's do this. We can do it. We can move it somewhere closer at the edge so that you can see how it runs. What I'm going to do, I can grab this. I want to do it again. I can just move it and bring it somewhere here at the edge so that we can at least see it very well and nicely. So it sits just next to that connector. And of course, if you explore this, you'll see how now the vias run all the way, say from the second layer to the other layer. Of course, it's difficult for you to see here, but of course, if I do something like that, you can see now how all the vias are interconnecting here inside. Of course, you can find a blind via somewhere here at the top. Let me see. Almost saw it here. So of course it's somewhere here. Somewhere within sandwiched between layer 2 and layer 3. Again, so how to get to that point? You just go to your preferences here, go to display options and disable this feature, show board body. Just make sure it's unchecked. For this case, I'll just check it back. So that's of course that's a tip, of course, I'm giving you, hidden tip, of course. So what's the aspect ratio? So the aspect ratio is how many layers are we going through with our via, say from top to bottom, say from 2 to 3, from 1 to 3, 1 to 4. So there are certain aperture or other aspect ratios that the fab house will do. In most cases, it will be 1 to 3. You can never exit. Like say if we are on a 6-layer board, we cannot have a buried via running from 1 to 4. Maybe we have one that runs from 1 to 2, and maybe 2 to 3, and now 3 to 4, or 1 to 3, at least the maximum. Because again, this is dependent on the type of tools that they use, because these such vias are actually embedded using lasers. So the strength of the laser, of course, it cannot go through all those layers. So we have to go like the maximum you can have is 1 to 3 and 1 to 2. Now say 2 to 3 and 3 to 4. So that again you have like those buried vias. So what's the annular ring? Annular ring is actually the area between the edge of a drilled via and the copper pad connected to that particular hole. So let's see it practically here. So basically, the annular ring is, you see this copper here, and that's basically the annular ring where all the copper extends. That small bit of the copper, that's the annular ring. And of course, in pads, it's very easy to show an annular ring, say in pads, because at least pads are quite big. So the annular ring is, say, from this to this edge, where you have this gold copper all the way to where we are starting the purple line, and that's the margin. So this is the annular ring here. Of course, it's well indicated here, the dimensions. So when you are doing your vias, say you are changing your vias here, it's very important because at times you might set something when you go to your board setup here and say you are doing your vias here. Like you can see for this case, I'm doing 0.6. This is the via size, but the drill is 0.3. So you can see that I'm having some very good annular ring such that I'm not going beyond my fab house limits. So this is something that you have to consider so much when, of course, you are selecting different vias and say you're not using the default via size on KiCad. And of course, we'll dive much into this and how we can adjust all these particular sizes and stuff. So another important thing is the solder mask. What's the solder mask? I know most people hear of solder mask. Hey, what's this and what do we consider here? This is the thin, varnish-like layer on the of polymer, usually applied on copper traces on the PCB for protection. So it has several uses. It's not mostly about the aesthetics. It's about protecting the traces, the copper traces from oxidation, short, talk of dust, and also prevents solder bridges that could form between closely packed component pads. I'll show that. And it's usually green on default. So what you see as green, it's not copper, it's not a thing. That's just solder mask. And its work is for protection. Yeah. And of course, like for this particular board, I did change the several solder masks so that at least I can show you that you can even have several solder mask colors from KiCad. Here we are having red, here we are having green. So what's important to consider here? So let me go back here and talk about the solder mask just a bit. So what happens? Your solder mask, it will always be on the top. So what happens is that it pours in between these traces here, so that when we are talking about solder bridges, you find that at times these traces are very close, or these pads are very close. And when we are doing the soldering, solder might bridge or might overflow to this other pad, shorting it. So what happens is that if you have solder mask here, it will of course prevent solder from actually forming around this edge, because what it doesn't allow like copper to stay on top of it. So it will quickly squeeze on this side or either this side. And this attributed, of course, you can see when you are soldering your boards on say PCBs that do have solder mask, you will see that copper will tend to like even go towards the pads. That's of course is the work of solder mask. Important to note here, the color that you select for your solder mask actually really affects the sizes. You find that some fab houses that all colors do not have the same clearance. Like we had an issue when we were using white because they needed a bigger clearance. Say like I remember it was 0.22 mm. So and that of course had us changing the pad sizes here so that the solder mask could easily flow. Because what the fab house will tell you, if you don't do solder mask here, we are not going to ascertain you that we are not going to get short in these particular pads. So it does play a very critical role when you are doing that. So it's also very important that you check with your fab houses what are their limits in terms of the solder mask and how can it flow, say, when you're having such pads. So when I'm talking about now here, when you're coming to solder now, these particular edges here. So solder mask is what you'll find now that it's actually that flows in between here, here, and here, such that when you are soldering this, it doesn't overflow to this and cause some short and stuff like this. So I will go back to this. So of course, I talked about color and how it affects, because you'll find that some color need more clearance for them to be applied by your fab house and stuff. And of course, the spacing, we are talking about the clearance between the pads. Seal screen. I did mention about the seal screen. I want to mention it about again and dive deeper in it. This is actually the layer that does carry all the text in your PCB. So what do we consider here? We're going to consider the color, of course, the color that we want our text to appear in. We're also going to consider the minimum height and of the text, the width and the height. They do play a very big role. You'll find your fab houses telling you we can do up to these limits. So again, select within the limits when you are doing the sizes. Minimum clearance from copper. So I'm going to showcase those and what they do mean. So I'm going to go to somewhere like where we have a resistor here. So the clearance that we are talking about here is that how close is it to the copper here? So we have some minimum clearance to consider by our fab house. So again, you don't want to have your text going like and overflowing all through the pads here. You want to keep it just not very close, but outside the pads at least. That's one thing. Again, the dimensions. If I hit E here, I'm able to adjust the sizes here. You see I'm having the width as 0.75, the height as 1, and the thickness as 0.15. So you find that fab houses will give you some minimums, like they cannot do more than or rather less than 0.1 sometimes. So it depends with the fab house that you're using again. This is a typo here. This is supposed to be solder paste, not solder mask. We've talked about solder mask. So solder paste is the material that's applied on the pads to assist in soldering, say, and especially for surface mount components. So the fab houses, what they will do, they will apply such, and you can see it here. These are not just pads. They have applied some solder paste. So, and once now they place the components here, once they do apply heat, now the solder paste now is going to just like melt, and so that forming in together and binding the pads in together so nicely. So that's why you see the companies when they do your PCBs, it's nicely done because, well, again, they're going to put it in the oven so that the solder mask will now just melt nicely and form a very good joint with your pads. Gold fingers. You might have heard of this word. Thought it's very important to mention it at this particular point. So gold fingers, essentially, these are edge connectors or contacts that are used to protect pads and make connection to other devices. A good example is your hard disk. You can see that they do come here at the edge. So anytime you hear like, can you do some gold fingers for me on this particular design? So these are the type, this is what we talk about. And their use case basically is for protection and also ensuring that it actually lasts for several years without wearing out because of the finish that we have on this. So these are some of the basic principles that you've heard about them here, that we've been probably mentioning some and you have not known what they do mean. So I thought it would be very wise that we have these principles so that at least when we mention of anything very technical here in terms of and what they do, because we can assume that someone knows what a solder mask, we can assume they do know solder paste and such. So that would be very important that people get to know these particular tips and how they are used.